Good evening, friends. This is where we had stopped, although still we just started, because ideally we didn't do anything much, just extracted the information. Okay, so we are attempting question PQR, which we had a fixed budget and an actual report. Okay, and our task is to flex the budget and then determine the variances or comment on the performance so far. Okay, and I've just told you that the whole point of flexing is to make two tall people, or to make a comparison of two short people. Okay, so in this scenario, we had already agreed that production is much higher than it is for in actual as for the fixed budget. Okay, the actual was much higher, and we're saying the only way you can compare or measure the performance of the actual is if you flex this fixed budget to measure the same height as the actual. You say therefore, we shall put the units here as 12,000. Okay, the fixed budget production must always be the same as the actual production. Okay, so now our task is to now determine the sales revenue for 12,000 using the fixed budget. Okay, determine the variable costs for the 12,000 using the fixed budget. Okay, so for the variable costs, it's really easy. I understand you learned a new method, which is using what you call a flex ratio. Okay, which is given by the actual production divided by the fixed budget. Okay, and then and this ratio, by the way, only works for variable costs. I can emphasize it only works for variable items, not necessarily costs, but variable items, including revenues. It works. Why does it work? Is because like the ratio is here. I'm going to show you my other method. Like the ratio it is here that you're dividing the actual, which is 12, by the fixed 1.2. And then you attach the 1.2 on the cells itself, the entire value itself. Okay, to come up with the flex budget, you're saying it is equal to this 12 actually. It may be the actual, but actually this flex. Okay, so this 12 divided by this 10 times this. Then you end up with 120. Okay, that's how we apply the flex ratio. However, with me, I would encourage you to use what you call the variable item or the variable unit. Now, for example, sales, your task is to determine the selling price, okay, of a single unit, and then you attach the number of units. And you can try out that and we see how it will look like. So I know that the selling price is 10,000. If it's not given, you will get it by getting the sales, total sales, and divide by the number of units that you sold. And you end up with a 10, which is this, okay, selling price. Now, this selling price, you now attach it on any quantities that you have to determine its revenue. For example, for the 12,000, we're saying you get the selling price times the number of units sold, which are 12,000. And you must get the same answer, 120. Okay, that's my idea. And feel free to use what you're comfortable with. How was the actual and fixed overheads gotten? They were given, like I already told you, that for the actual, the overheads were given as, for the fixed, it was 11,000. It is in the question. I hope you can have the question as well. Topic 2, it's a PDF. advanced budgeting. Okay, PQR is the question. This information was given as it is. Maybe what was not given is for direct labor, it was given as a total. Okay, they added this 17 plus the 11,400 to give you 28,500, which I've shown you that you split based on the condition that was given. They say that 60% of direct labor is variable, then 40 is fixed, of course. So otherwise, the information is given in the question. You don't do anything regarding actual and fixed. The way it is the way you put it there. Pardon on your formula without using ratios. Okay. Where I have not used the ratio, we're saying that you determine the cost per unit, what you call the amount per unit, what I put here. Amount per unit. That in case I had sold only 1 unit, how much would it be? Okay, now for the sales, we're saying for a flexible budget, if they didn't give you the selling price, they will give you the total sales and the number of units. We're saying to get the amount per unit is as easy as getting the total sales divided by the number of units sold. And have this as 10,000. Now, if it is 10,000 per unit, now we're saying our units are now 12,000. How much should it be? So you get the 10,000 times 12. You get the same answer, 120. Let's go to the next item. Maybe you'll understand it better. The next item. Now, when you go forward, the next items are variable costs. So I can already say that this is where the ratio applies, and so is my formula. That as long as something changes vis-a-vis change in production or in the number of units or in volume, we're saying you can get the cost per unit. Okay, let's sample. Now for this one, if you have to go with the formula that you guys have, where you apply the flexible ratio or the flex ratio, you would say it is equal to the ratio itself, yeah, times the total variable cost, which is the 50,000, and to give you 60. Okay. Now, if I go with my formula, we're saying that first determine the amount per unit. In this case, since they are costs, to be the cost per unit. How I get it is I'll get the total cost, which is 50, divided by the number of units that I've produced. Okay, and to give me 5K. Now, 5K is for a single unit. If I want the total direct materials for 10,000, I'll get 5K times 10,000 to give me this 50. Meaning, if I want for 12,000, I'll get 5K times 12,000, which will still give you 60 here. Okay, so Sumaya, I think Yudon was interested in that. So you get the same answers. Now we go to direct labor. Direct labor still, these are variables. By the way, the biggest trick is on semi-variable costs. Whenever the semi-variable, then you have to do something. You don't just shine, don't just come and give us your ratio and then put an answer. No. Okay. Aaron, I think you will get from this one, from direct labor, so no worries. Now, direct labor, we're saying all these items that are here are variable. Okay. So for the ratio, I said you'd say it is equal to the ratio, which is 1.2 times the total direct variable cost, or total direct labor hours that are variable, and it will give you the 18. Okay. But if you prefer the formula that I've given you, you get the variable cost per unit first, which is given by the total cost of 15. How many did it bring in on board? It brought 10,000, giving me what? 1.5. 1,500 direct labor hour cost per unit. So for the 12,000 units, how much will it be? To be the 1.5 times 12. And you must get 18,000. Okay. We continue. Variable overheads. Same thing. We're saying that if you use the ratio, it's going to be the 1.2, which is the same as 12 divided by 10. Okay. In other words, 12,000 units divided by 10,000 units, give you 1.2. That's the ratio. And then you multiply it by the total variable cost. Okay, the total, which is 12,500. That's what you'll get. Okay. If you apply what I just told you, you don't do both. You choose one. You don't do both. If you go with what I've said, preferably you mute, because I don't think you guys your network is. Whoever is asking the question, I'm not checking it. Okay, so saying for variable overheads, you still determine the variable cost per unit, which is this total divided by the number of units that you brought on board. Okay, this is the per unit. So for me to get this cost here, I'm saying it is the variable cost per unit times the new number of units that you have, which is 12,000. You have this. So that is for variable, and that's how we apply it. Now for fixed components, you know what it is. That's what it was, is what it will be. Okay, that there were 10,000 before, and for 12,000 it will still be the same amount because it is fixed. It doesn't change with a change in volume. So this is how we get these figures here. So if I get now the variance is between the flexed budget and the actual. Why? Because they are of the same height. Okay, they are of the same height. So if I scroll through, and I preferably always have them as positive always. So what it is that it's always big minus small. Okay, I think this part can extend it somewhere. Okay, so I was still saying that for the variances, it is always big minus small. Don't have negative values here. Okay, after all, we're going to have the comment section. If you have in the comment section, then why should you have negative variances? Okay, the comment will tell us that this is negative or positive. It's a good thing or a bad thing. So for sales, we shall say the big one is actual minus the small one, which is 120, the budget 2,000, and we're saying this is favorable. How you know that something is favorable or adverse or unfavorable is that for revenues, for all revenues or incomes, you want to maximize. Okay. By maximizing, I'm saying we want big things. That's for incomes. Then for expenses, so because we want big things, we are saying that, let me just add on here. Because we want big things, we are saying that thus actual, if it is greater than budgeted, emphasize flexed budget. Flexed budget, saying this is good, this is favorable, because we want big things. Okay, the reverse is true. Then for all expenses, what you call costs, all liabilities, we want to minimize. We want as low as possible, small or little. That's what you want, because you want to spend a lot. You don't want to go into much debt. You don't want anything bad. You understand? So because of that, you're saying thus, if actual is at this time greater than flexed budget. So for this one, it is adverse or unfavorable. Favorable stroke adverse. Okay, and the reverse is true. So that's how we comment on variances. So if I come here, then I go to the next item. These are costs. Now for costs, you begin thinking that I want minimum. So if your actual is smaller than budgeted, that is a good thing. Now this one, cost is indifferent, you're neutral. Just the same. But now for this one, we're saying that our budget is bigger than our actual. So this one is what? This one is favorable because these are costs. Okay, costs, whenever your actual is lower, you're doing well. Then we continue. This one is still indifferent. Then for the fixed budget, actual is big. So this one is adverse or unfavorable. Stroke unfavorable. The same thing. Okay, why? Because you're spending a lot. So the same thing here. This minus that is adverse. So guys, that's how we deal with flexing of the budget using your ratio and variable cost per unit if you wanted to. Let's go back to the question and continue. Any questions regarding this? Okay, no questions. So we continue. So we had the rolling budget. Okay, I understand you have a question, but I will illustrate. For a rolling budget, since I don't have it here and I'm not going to look for it, let me illustrate. If it is an annual budget, it has 12 months. Okay, you're saying you have January, Feb. Let's use quarters because to be too long. It has 4 quarters, so we say quarter 1, 2, 3, and 4. These are quarters. Okay, and these were your cells. They maybe have 2M, 2000. You have 1,500. Here you have 3,000. Here you have 3,500. Assuming these are in millions. Huh? Okay, that's your information. And this is your budget. Okay, now, should it occur that you went into the first quarter, finished first quarter, okay, and your actual was maybe, in terms of sales, it was maybe 1,800. Okay, that's your actual. Now, it doesn't matter what your actual is. Okay, what matters is what are the new expectations, conditions. It's the most important thing. Okay, so if they give you a condition, they say that the sales will increase. Sales will increase by 2%. That's what I've told you. Now, the actual, guys, it has nothing to do with the budget. It has nothing to do with the budget. What happens is that you come to your budget here and you know that we are now rolling it. We are rolling the budget. Okay. We know that quarter 1 is gone. That's why you have actual performance. And you actually got a variance, which is even negative in nature, adverse. Of 200, which is okay. We're saying, okay, now our performance is not good. Then you do the needful. Maybe you hire new staff, you maybe improve your products, you make your market, whatever can increase your sales is what you will do. Now, the rolling budget says that in case one period is gone, you update the budget so that it must always have, it must always keep the same size. If it is 1 year, it must always be 1 year. if you already have an actual performance of a quarter one, we are saying that means that you're only left with quarter two, quarter three, and quarter four. And these three do not make a full year. So you're supposed to update this budget and add an extra month or an extra quarter. In this case, of course, this will be, maybe if this is the whole year of, I can use margin. If this whole year is maybe 2019, we're saying that, okay, it's 2019, all right, but we have consumed already January. So we need to keep the budget full 12 months. So what we do is you get these 12 months, these 2 months here. For me, just borrow this information. Copy. Okay, if I may copy the way it is, you're saying that, okay, quarter one is gone. Yeah? So meaning that you only have meaning that you only have now 2, 3, and 4. And these are only 9 months. So rolling says that you get Ogatakeno, you add something this side. Okay, you add this side. But as you add, of course, this will be quarter one for the next year. Okay. So you have 2, 3, 4, and 1. Okay, quarters you don't have fifth quarter and ninth quarter. No. You have quarter 1, 2, 3, and 4. But it doesn't change the fact that these are now 12 months. Okay. So what changes is maybe the value now in quarter 1. You use the updated information to forecast the new quarter. And what was given is that they say that the expected sales will increase by 2%. So you come here and increase this previous one, not the actual, like I saw with the class work. You increase the quarter with what? With the 2%, 0.02. Okay, and then you have 3,500. Now this is the new or the updated new stroke, updated budget. That is how we do rolling. Okay, the rolling budget says that you keep the same length, okay, such that whenever part or the portion of the budget is consumed, we update the previous budget by adding an extra period on the next. I can show you the definition. Here they say that, have I shared the screen? I hope you can see it. They say that rolling budgets. The budget is updated regularly on short-term intervals, and as a result, uncertainty is reduced. Okay, you can even Google and see about it. Rolling budget is continually updated to add a new period or budget period as the most recent budget period is completed. Okay, if you see these images, I don't know if you can see it. Okay, if you see this image, you see they'll tell you that you have year one, it's quarter 1, quarter 2, quarter 3, quarter 4. So there's supposed to be 4 quarters at all times. Now, if during the rolling budget, if quarter 1 is gone, like we saw, you have already consumed, we are now in quarter 1, meaning that our future period is supposed to begin from quarter 2 going forward. We shall come to quarter 2 and extend the existing budget by 1/4 what you have spent. And as you can see, they go increasing the quotas depending on what you have consumed so far. So that at all times you have 4 quotas. I don't know if that makes sense or it doesn't for you guys, but that's how we do rolling budgets. And depending on how you used it percent. Okay. How did you apply the growth rate? All right, no problem. So if I may take you to, I hope you have understood what rolling budget is. So let's come back here. The 2% is you come on the existing budget as what is remaining, the remaining future. Now you update the last period. You don't come and change these values that are already established. Okay, what is coming as new is what you change. And as you change it or as you come up with it, it's dependent on the previous period or on the last period. They said it is 2%. So you just increase this one here by 2%. 2% of 3.5, you get 70. When you add 70 to the 3, you get 3,570. That is how we apply it. It's an increase. I hope I've answered you people. Okay, we can continue. Sensitivity analysis, simulation, I think you guys will look into it, but for sensitivity analysis, it was an objective. It is that tool that helps you to obtain the most important variable. If you have more than 2 variables, sensitivity analysis helps you to analyze which variable is most important. That if you're saying you have management, supervisors, and senior staff, those are the 3 people. What's their impact on the net profit? The most important variable or the most important person there will affect the profit significantly. Now that person is what we call is the one that raises the sensitivity analysis. That we do sensitivity analysis to see who is the most important person or the most variable factor in production. Okay, then simulation is what happens is that whereas for sensitivity you're trying to check the most important by holding the others constant and you only change that one that you're trying to test. For simulation you're going to change maybe 2 of them or 3 of them at the same time. Okay, so let's continue. Feedback and this one I don't want to go into it. I think it's a theory. High and low. I think we all know high and low. So you update only 1/4, not all. Davison, yes. You update in a way that you remove the first quarter or the already consumed quarter, and then you include another quarter at the end. So that at all the times you may have 4 quarters. That's the whole point of rolling. I don't know if I've answered you well in that regard, but I hope I've done that. So we go to quantitative analysis of budgeting. You have the high-low, which I said you have an idea. You can maybe look at a question. I won't do the entire thing. I'll just do a few things here. I don't feel like doing that because extraction. I can just take this. Okay, so this is the information you have. You want to apply high-low on this information and then make an estimate of a few things. The other one is the question I've skipped is it's the same, only that it's theoretical, and I don't want to go into theories, but it's the same thing, the same logic that they get you the volume and get you costs. That's what high-low depends on.
But I was pardon on sensitivity.
Okay. For sensitivity, I've said that it is a tool used to determine the most important factor, the most important variable. Okay, if it was an equation, you have 2x plus 2y or 3y is equal to 5, or is equal to 10, whatever it is, or is a function f of x. And what they're saying is that these two factors, x and y, are okay, in this case I've used only two. We're saying that we try to analyze which variable is most important or affects our function. If it is a profit function, that affects our profit function significantly. Okay, so what it does is that you're going to hold one variable constant, say y, you keep it as 1, 1, 1 as you change x, to see the impact of the x on the x function. Let me sample you something using this same information. Okay, our variables are x and y, so you have x and y, and then you have the resultant, which is f of x. So we're saying if you're testing for which variable is most important, we shall begin with say x. Now, what happens is we shall say let y be maybe 1. Okay, in all scenarios, it's 1. So if y is 1 and x, I'm going to try to keep changing it so that I see it's changed, assuming that I'll begin with 1 here. To be 1, which is 2, plus 3, which will give us 5. Okay, in this function. Then if I change it to 2, you're saying it's going to be what? It's going to be 2 is to be 4 plus 3 to be 7. If I make it 3 to be 6, then that will be 9. Okay, by doing this, you're doing what we call sensitivity analysis. Okay, now you have changed x. Assuming you change y, what will happen? Okay, if now the ones are for x, okay, and you're now changing the y, what will happen? We're saying if you hold y constant to be 5, of course. If y is 2, this will be 6 plus 2 to give us what? To give us 8, isn't it? This is 2. F of x will be 8. If y is 3, we're saying it is 3, okay, 3 to be 9, 9 plus 2 to be 11. So you can see from this information that if I change x, the impact is not really significant. You see the change. You have 5, 7, and 9. But here the difference is by 2, by you can get the differences from here. 7 minus 5. By increasing x by 1, you have an increase in function of x by 2. Okay. Same thing here. It is a 2. Okay. But for y, if you change y, what happens is that the change is actually 3. Okay, so this implies that y is more important than x. That's sensitivity analysis. You hold one variable constant, or the other variable is constant, and then the one that you're trying to test on to learn is the one that you keep changing. And then you see its impact on the entire function, or an entire production. So in conclusion here, we're saying that y is more important because of the change that it brings about. I hope I've answered someone who asked about sensitivity analysis. One variable is active and the other is constant. Yes, Bridget. Okay, but you do for both so that you know which one is more. You do for all variables so that you know which one is very important. So let's continue. So yes, so we're going to talk about high and low. Okay. So for high and low, given the information that you have, if I may share the question which you already have, I said you scroll, shall leave the theory part and just do this one instead. Illustration is on page 7, the last part of page 7. The point is sharing the idea rather than doing the numbers. So I hope we're together. But in case you try out this number and you have challenges, feel free to reach out to me. Okay. So for high and low, if this is the information, any pair in this thing is all right. Any pair. Although someone may want to consider the entire information and therefore choose the highest, which is here 420, and it goes with its cost, which is 2.4, and then the lowest, which is 300, and its cost. Okay, so you will go with August and October. That is if you consider the entire information. But even someone who considers just July and August, a pair is also good to go. You get the same answers. So let's go with what majority would think, which is highest and lowest, which is October and August. So my information for October and August. October it was 420,000. This is in volume or units. Then you have the cost. Call it the cost. October it was 2.4. Okay, then for August, you have 300. So if I may explain maybe the high-low, what is it all about? Because someone may wonder what I'm doing. The high-low analysis is a technique that uses split variable cost. Okay, the high-low tries to separate some variable costs, but when you have these total costs, which are inclusive of the fixed costs and variable costs, they're saying that you can apply the high-low method to split so that you know what is variable alone and then what is cost alone. So the high-low method says that, okay, I think the link is going to close shortly, so kindly join again in the next link. Can you please go through the first example of high? I was avoiding it for purpose. If I don't do this, if I do this one, okay, I'll do the other one, I don't do this one. Okay, I just want to avoid it because it's going to take us some time, which is unnecessary. Okay, but we shall go with what you prefer. We shall do the first example. So kindly join again in the same link, and then we continue.